welcome to my build of D0. This D0 project, as you may have seen printing most of the parts, was designed by Michael Baddeley and uploaded for his Patreons. I'm going to assemble this making note of some of the things I found and some of the issues I came across. The lead shot has already been put into the various locations where it had to go and two-part epoxied into place. I've inserted a number of nuts throughout these pieces, and these have been plastic welded into place. While hot glue would have worked, I like the plastic welding path. I've actually had all this together to make sure everything works, and actually had video footage of that, which has been since uploaded. This has now been disassembled most of the way down, but some parts I can't disassemble, such as this wheel assembly over here, because the wires going through this tube have plugs on the ends, and those plugs are not easy to remove. And the plugs are on both ends. So let's start with the base. Now these two covers, there is a right and a wrong way to put them on. If you put them in the wrong order, they'll overhang and not fit properly. They are slightly different. Okay, when you're assembling these parts, make sure you use a relatively high infill and high wall thickness on this flexible component. It does break easy or fold up on itself if you don't. I had all sorts of trouble during my demonstration of it out in public when this started to fail. The other problem I ran into in public was this slipping on this copper shaft. To get around that problem, I've drilled a small hole that this screw will locate into. Make sure you don't go in too far because you don't want to damage the wires. But that solves that issue. Now, you may want to put a little bit of epoxy glue or super glue to hold this bearing into this hub here. If it comes loose, it will be difficult to fix because of this one shaft with the wires through it. Right, so me hole in the copper is actually lined up with the hole for the screw. The wires will just move back and forth through there. With the screw done up, is now bound into place. It's not moving, and that's all registered through. I haven't done the screw up in the bottom down here to lock it onto the copper pipe going through. I'll do that when I put the head on. I've plastic welded the nuts into these parts. I think I did that in a demonstration of a 3D pen. What I also found is the servos I used are slightly different spec servos to what was listed in the build. The servos listed in the build are a relatively cheap servo. I haven't had a good run with them with the in-move build, and I've gone to the slightly marginally larger servos that are a better build quality. So what I found is I had to pack out the bottom of this with a washer, and that way it sat down flat. If I didn't do that, then it kicks the wheel out and it actually has them spreading across the top. So by putting the spacer washer in, I eliminate that spread. Now, we want all of the servo wires to come out on this side. That's because once this piece is on, the servo driver board, the Adafruit 16 channel I2C driver, will sit here, so we want all of the servo connections over to here. In Mr. Baddeley's build, what he did was the two servos from the head, he took to the Arduino. I think he used a Uno, or at least that's what he's listed on his instructions. And I have found that it's not really necessary to do that. You can run it off the PCA servo driver board, and so that's what I've done. That means that all of my servos are coming off that one location. It doesn't hurt, and I'm actually using a voltage regulator, so I'm only getting 6 volts through to that driver anyway, so everything is relatively safe. I think now's a good time to put this board in. This is the PCA 9685 16 channel 12-bit PWM servo driver made by Adafruit, or designed by Adafruit. These are actually a very good little unit once you get past a few of the little interesting quirks. Where you connect these wires onto here is dependent on your program. You can actually configure the program to use any of the ports. In this case, I'll be using the highest numbered ports for these wires, and these ones coming up from the servo, or from the head, are going to be plugged in up the top to port 10 and 11. So I decided a while back to use port 15 for this side drive motor for the wheel and 14 for the other side. So this is 14. Now these will have to be bundled up and made neat so that they don't get caught up in the wheels and the gears. That's all pretty straightforward. Now for the other variation that I've made, this is a switch mode buck power supply. It has a built-on power switch. In is actually off, out is on. You can adjust the output voltage with that little screw here. Light comes on when you've got it turned on, and so I've tuned that up to give me 6 volts on these wires. It's 7.4 volts coming into the input terminal, and I've actually taken the 2 batteries, and this device here is actually a dual diode in a single package. So we feed the red wires or the positive from the 2 batteries, one on each leg, and the common output comes out and goes to the power supply. This means that if you have a battery plugged in here onto this terminal, this plug here, shorting these 2 terminals together is not going to do anything because the diode will prevent that from causing a short. I think you lose 0.6 of a volt through there, but I think it's worth that loss of 0.6 of a volt to prevent an accidental short and destruction of the robot with the battery in it. This gets mounted. There is a cover supposed to go onto this piece. I have discarded it, preferring to use this instead. This nut I haven't welded in here, so that's why I've put the screw back in here for the moment. Now to keep everything neat and tidy, I've put a screw through here and into one of these holes. I think it's the top hole I actually used in the end. And so it doesn't go all the way through, I put a nut on first. That acts a little bit of a heat sink. Not a great deal, but a little bit. Now I drilled a small hole first and then threaded in the M3. And that keeps that diode safe and stops it from flopping around. I'm using the original hole for the cover to actually hold the switch mode power supply in place. Now I made that plug just out of a bit of header socket. That seems to work quite well. That cover can go back on here. You can see my wires coming up through here and then across, and that's just a bit of pin strip for plugging into headers, and I can plug the servos into those. Okay, so Now we've got the batteries in, we can fire it up and you can see the light comes on and we actually have power, but there is no control system, there's nothing to make this work. The servo driver needs a signal of some sort. So let's look at the control module. This is an Arduino Uno. This is a DF player MP3 player. Buried in down here is a FlySky receiver, 6-channel receiver, and I'm actually connecting just the servo signal, iBus servo signal, through to the Arduino Nano, and then this ribbon cable here goes to this plug to connect to the servo driver. I'll do another video on the actual control and the programming of it later on. So let's get this plugged on. There's a magnet glued in to hold it in place. This plug simply connects up to here. Now the brown wire is battery voltage from this terminal block here. The red wire is 5 volt coming back from the Arduino Uno. So the red wire is connected to V in on this, and the red wire is connected to VCC. The orange and yellow wires are the I2C bus, clock and data. The green wire is an enable signal. It has to be enabled for this to work and actually drive the servo. So we can actually turn them on and off, and I've connected it to D2 on the Nano, and the blue wire is ground. The speaker will get hot glued into place down here. Put this cover on so I don't lose it. And we'll hot glue melt these onto here and here, as well as hot glue melting the speaker in. And I'll just have to get a cable tie to tie all these up. So I'll be back in a minute. Okay, so let's just hot melt glue this into place so that it doesn't come loose. By only doing one side, the magnet will hold it down and it'll act like a hinge on the hot melt glue, which is easy to break at a later date. Now we can put the big wheel on, which runs in on these bearings. It's not driven at all, other than friction through the bearings. It's surprising how well it works. Okay. Now we can push the button down through here to turn it all on. and part of the program I have is to actually play one of the sounds just to let me know that it's all initialized and ready to run. This side cover just clips on with the magnets. Still running out a little bit on the outside, but that runs quite nicely on the bearings. Now the head assembly has been hot melt glued. Push this back a bit. This part's been hot melt glued onto this. In here we have the top plate, which the head is screwed to. There is a servo in here, another one underneath it on that, and that's screwed down to this. And it's a pain to put together and pull apart. But this just plugs onto here. I'm just using a rubber band to hold the two servo connectors together, and that way I always get them plugged in the right way round when I have it apart. Now this is 3D printed screw, and it just screws in there. One of the things Michael Baddeley did was try and make the top as light as possible, and it all appears to have worked. I'll talk more about this remote control in a later video. And the way I connect it to D0. So if I turn D0 on,